This is the solution video for free response question 7, part A. All right, so the question says a continuous function g is defined on the closed interval -8 to 6. The graph of g shown above, which I've drawn here, consists of 3 line segments and a quarter circle centered at the point 0, 2. Let f be the function given by f of x equals the definite integral from -8 to x of g of t dt. All right, so A says find all values of x in the interval -8 to 6 at which f has a critical point. Classify each critical point as a location of a local minimum, local max, or neither. Justify your answers. All right, so what we need to remember, okay, is we're trying to find the critical numbers of f. All right, so when would f have a critical number? So f has a critical number when f prime equals 0 or f prime is undefined. All right, so f prime 0 or undefined. Well, what is f prime? Well, if f of x is the definite integral from -8 to x of g of t dt, then f prime of x, according to the second fundamental theorem of calculus, is found by taking x, putting it in for t, and multiplying by the derivative of x, which is 1. So f prime is g. So in other words, this graph, yes, was told to be g, but it's also f prime, right? Because those two things are equal. So we want to know when uh, f prime equals 0. So when this graph equals 0, so that would be at -6 and 2. All right. Now, it also has an endpoint here, right? And equals 0, and has an endpoint here. But notice it told you that we're only looking for values of x between -8 and 6, so not including -8 and 6, so not including the endpoints. So we can say uh, f has critical number when f prime equals 0 or f is undefined. So at x equals -6 and 2, right? So that's the first thing. We've identified the critical numbers. Now, classify each point as the location of a local minimum, local max, or neither. All right, so remember, this is a graph of f prime. So if f prime is 0 here, to the left of it, f prime is below the x-axis, so it's negative, and to the right of it, f prime is above the x-axis, so it's positive. So that means f prime changes from negative to positive. So remember, if you're looking at a graph of f and its derivative changes from negative to 0 to positive, you have a local minimum. All right, and then at 2, f prime is 0. And so to the left of it, f prime is above the x-axis, so it's positive. To the right of it, f prime is below the x-axis, so it's negative. So it changes from positive to negative. And so remember, a graph of f that's derivative changes from positive to 0 to negative would be a local max. Okay, so you would say there is a local maximum at x equals 2. Why? Because f prime changes from positive to negative. All right? Then you would say there is a local minimum at x equals -6. Why? Because f prime changes from negative to positive. All right, and so that is it for part A.